Hello.
Hello, everyone. And another session in the data track on the Dev Days European Conference 2022. Stay with us because we have prepared lots of interesting talks and topics, and make yourself comfortable and enjoy. At the end of the session, we'll have some time for a Q&A, so you can write your questions in the Q&A section whenever you want and you have one, and our speaker will be answering them at the end of the session. Keep in mind also that our Knowledge Partner Pact will be giving away 20 ebooks to the most active conference attendees. So we urge you to participate and be active, rate sessions, leave comments, ask questions, and you can win a great ebook from our Partner Pact. Okay, let me introduce you our speaker for today. We have with us David Pilato.
Hello.
David is a developer and evangelist at Elastic and French spoken language user group creator. In his free time, he likes talking about Elasticsearch in conferences or in companies. Our topic will be advanced Elasticsearch for your legacy application, and this live coding talk will show you how to add Elasticsearch to your legacy application without changing all your current development habits. It will be a very interesting talk. David will also start from a Spring Boot Post GRE SQL based application and will add a complete integration of Elasticsearch, and it will be all live from the stage during the presentation, so I'm sure it will be a very interesting talk. David, I'm giving you the stage. It's over to you.
Yeah, thank you. So I'm going to share my screen first. Yeah, there we go. So you said everything, so that's perfect. Thank you. So basically, this talk is based on my own experience when I was working at the French custom, and I was sending data to a database. It was Postgres at this moment of time, and what I had to do was to connect to a search engine like Elasticsearch. So this is basically what I'm going to cover today. So everything you are going to see is available on my repository on GitHub, so you can check it out. There are multiple steps I will perform live, and those are the name of the branches which correspond at the steps we are going to see. Hopefully we will be able to do everything, but we'll see. So I have an existing application today, and this application is managing people. It's like a marketing data that we have. So here I have the beans view. So this is a Java application. And the beans that I have, the main one is the person bean, where I have a name, an address, some marketing data, the date of birth, the gender, and the number of children. If you look at the address, in the address, I have the country and the city and some geolocation point, latitude and longitude. And the marketing information are just counters, like marketing data, as I said. I'm using Spring Boot here and a bit of Spring Data behind the scene, which is using Hibernate. And Hibernate has generated this SQL database for me, depending on the settings that I set. So here I have my person table, my address table, and my marketing table. So basically, this is what I have. So if I look a bit at the code, I have, and first at the application itself. So what I have in the application is the here search bar where I can search for entities that are in my database. So for now, I have nothing in the database. So what I need to do is to inject first some data. So for that, I have an injector here, and I can inject randomly and generate randomly some fake data and send that to the database. So this is what I'm doing here. If I look at the implementation here, what I'm doing with my generator, I'm building a collection of persons that I want to save. And I'm using this person repository, which is coming from Spring Data, where I'm saving all those persons within the database. Let's have a look at it. So, okay, so that was the rate around 34% per second. That's okay. If I go to the search part, now I can see my data here, and I can start searching for people like here, like Joe, for example. I have also the advanced search, and the advanced search helps me to search within specific fields. So here I can search within whatever fields I'm searching in, like the city, for example, searching for Paris. But here with the advanced search, I can search explicitly for Paris within the city field. and same for the name and things along those lines. So I have two type of searches. So everything is good. Let's have a look at the implementation, how it's made behind the scene. So let's look at this. Here I have this search method, and when I'm coming from the interface, whatever the user has entered in the search bar is the value that I will get here with Q, within Q. So if Q is empty, I'm getting back all the results. Otherwise, if Q is not empty, then I'm using this method within the person repository class, which is fine like Google. And if I open it, what is happening behind the scene? I'm selecting my person and I'm searching for what the user has entered here with a like person strategy within the name field, the country field, and the city field. Okay, so this is super basic implementation of a search here. So everything looks good here. So I can search for Joe Smith, for example. That works well. I can search for Smith, but not for Smith Joe. And why this? Because what I have in the database is Joe Smith and not Smith Joe. If I wanted to search for Smith Joe, what I would have to do is to extract from the what the user has entered, split at the space, and generate two tokens, and try to combine those two tokens within the query that you saw previously. Okay, so that's something. So if I make typos, it does not work either. So I would have to do some changes. So maybe complex, not complex, but I would have to adapt my search engine to allow the typos here. I said that I can search within the city field. I can also search within the country field. But look at the result set. Here I have someone in France, but I have someone in Italy. The fact that this person is in Italy is not the problem, because here I'm searching within all the fields, and as you can see, France is within the name field. So this is correct. But what I would expect here from a search engine is actually to make France Gall appearing at the top of the list. Why this? Because France here within the name is super unique in my data set. France as a country is not unique, so it's not super relevant to present all the France information on the top of the list. I should have France Gall on the top of the list if I was using a real search engine. So this is not the case here. And this is the kind of things that I would like to actually fix. And for that, we should use a search engine. And to me, Elasticsearch is the best choice, but obviously I'm working at Elastic, so you don't have to trust me, try by yourself and you will see. The question is now how you send the data from the database to Elasticsearch. So you have multiple strategies here you can think about. You can use an ETL. You can use Talent, for example, Mule ESB, or you can use Logstash. Logstash is one of the tools that we are producing at Elastic. But what are the problems with ETLs? Basically, the ETL is going to run like every 5 minutes to collect if there is new data in the database that needs to be sent to the search engine. And what is the problem with that? The problem is that when my user is going to click on the save button in my application to save a new entity, I will have to wait up to 5 minutes to be able to search for this entity. So it's not real time, and this is something I don't like and I want to fix. So this is something I did in the past when I was at the French Customs. Also, how you deal with updates and deletes. So what are you doing every 5 minutes? Are you going to get back the whole dataset again and index everything, or only the difference? If you want to get the difference, then you need to have a technical field, probably in your database, saying, okay, I have modified this entity at this period of time. Same for deletes. When you want to delete something, you need probably to have a technical table which contains the list of the deleted entities that you need also to delete in the search engine when the batch is going to run the next time. So I came to a conclusion that if you can, the best way to handle this problem is to modify the application service layer and send to Elasticsearch the data at the same time as you are sending the data to the database. So this is exactly what I'm going to do now. So to do that, For my application, the first thing I will need to do is to add actually an Elasticsearch client. So to add a dependency on Elasticsearch. So here I'm going to use the latest Java client that we have been released. So if you already played a bit with the Java client, so you will see that a lot of things have changed in the meantime. So be aware of that. So what I said that when I'm saving my entities to the database here, I want also to save to Elasticsearch. So what I'm going to do, I'm going to create a new Elasticsearch DAO class, for example, and I'm going to call a save all method, where I'm going to pass all the person which has been generated within the database. Why I'm doing that? Because when I'm calling the save all method here, Hibernate behind the scene is going to generate an ID, and I will use basically this ID that has been generated to have the same ID in Elasticsearch. So it will be easier if I need to find something by knowing the ID or doing comparison, for example. So let's create this. So that will be a final Elasticsearch DAO class that I need to create. This one, I'm going to create that in the DAO package here. Here I'm using Spring Boot and Spring, so I just need to annotate this as a component, and then I can just inject that into the constructor, and I have my Elasticsearch DAO class. So now I can start to create this method here. So, and I will create, okay, all the persons. Okay, let me change that. I prefer that. So what I need now, I need to have access to an Elasticsearch client. So the dependencies I added already will help me to get that client. So it will be Elasticsearch client. And let's call that S client here. And let's initialize it in the constructor here. So I'm going to automatically inject some code, and I'm going to explain all that. So first, I'm going to provide where my cluster is going to run. I will show you that in a moment. I will run everything in the cloud instance that I have. At Elastic, we are providing Elasticsearch, Kibana, and all the tools that you need out of the box on cloud. So you just have to start your cluster. Here, my cluster is secured, not with a good username and password, but anyway. So here I'm giving the username and password. There are other strategies that you can use. And with that, I'm building what we call a low-level REST client. So this low-level REST client is responsible to do all the HTTP requests and read the response. Then I need to create what we call the Jackson JSON mapper, which is going to be helpful. So let me add this as a field here. For that, I will need to pass a Jackson mapper. So we have a very nice library named Jackson, which helps to do the serialization between beans, entities, and JSON. So this is typically the mapper that I can inject here. So with that, I'm building a transport, and this transport is going to do the relationship between the low-level response and requests and Jackson. And then the Elasticsearch client will give me a Fluent API, which will help me to do everything that I need. So for example, one of the things that we can do to begin with is to call the client here and make sure that everything is running. I can call here the info method. Okay, throw an exception. And with that, let me get the info response. I will need a logger as well. So let me add a logger here. Yeah, this one. And what I can do, I can print that I'm successfully connected to my Elasticsearch instance. So to do that, I'm going to, yes, print that like this, connected to the URL, running version with the version number. So the cluster URL is this one, and the version which is running, I can get that from here up with the number. Okay. So with that, I should see something in my logs if I'm successfully connected. Then let me implement this part of the job here. So I want to save all my entities. For that, we have what we call the bulk API. And the bulk API is super handy to actually send a lot of data to Elasticsearch. With the new client, there is a Fluent API. So basically, I can use a lot of lambdas here. So I don't need to import a lot of classes. Everything is available out of the box, I would say. So let's return this bulk request. No, I can have an exception here. So let's build the request. So the first thing I want to add here, I want to specify in which index I want to send the data to. So I'm going to send all my entities into Elasticsearch in an index named person here. And then for each person, so this is a person, I will create an operation. And the operation I want to create here is an index operation. So let's call that index here. And the index operation, what I need to do, I need to specify here what is the ID of the entity. I said that I'm going to get back the ID from the database. So let's use the person ID as a string. And what I need to provide also is the entity itself. If you knew the old client that we have been using, you had to transform that to a JSON document. Here, you just have to send the entity, the object itself, and the serialization will be made automatically for you. Okay, so we are good here. I can save that. And there is an issue here where when I'm saving my entities to Elasticsearch, maybe something can go wrong. Maybe I can have an exception here. So what should I do? There are multiple ways to handle this. You can just throw the exception back to the caller, and it will roll back, for example, the transaction in the database. But here, I don't want to do that. For my use case, it was super important that anytime someone saves something in the database, it is saved, if possible, whatever is happening with the search engine. I don't care that an entity is not saved in the search engine. The most important thing is to save that in the database. So what I did was basically to try catch here and log that information. Actually, I did something a bit smarter than that. So you can say, okay, Houston, we have a problem, why not? With the exception. What I was doing, in fact, I was sending that information and the entity, which was failing, into a message queue system. And once Elasticsearch was back again, I was reading all the queue and sending that again to Elasticsearch. So that's okay here, probably. So what I need to do, I need to restart. And before restarting, I'm going to show you actually that I have my Elasticsearch instance running in the cloud. So here you can see that I have some deployments for multiple use cases. And here I have my legacy application, my legacy cluster, sorry, with Elasticsearch and Kibana that has been deployed automatically for me. So let me open Kibana. And once you open Kibana, okay, so I'm here. And what I'm going to do, I'm going to go to the dev tools here. And the dev tools is super handy to run queries against Elasticsearch without all the curl parameters that you need to pass. So here, if I'm doing a get slash is basically the same thing when I was calling info, the info method. So I'm getting here the same information. The other thing I want to check is that I don't have any person index I have nothing here yet, so my person index is basically empty. So with that, I can restart now my application and see what is happening. Okay, let's do that. Okay, so the application has started. If I look at the logs, hopefully I can see that, yes, I'm connected to my cluster and my cluster is running that version. So the connection is okay. So now we can start to inject documents. So let's do again, let's call again the injector as we said we did before. So let's do init here. And let's say I'm going to inject again 100 documents. So the injection is probably happening behind the scene. So what I can do now is to check within Elasticsearch if I have some data. So as you can see, I have 100 entities here in my index person. So the connection was okay. And I can start to search using the search API that I have here. We will use the Java to do that again. But now, at least you can see that I have 100 people that have been indexed. And those are the first entities that I have. So you can see the JSON version of the entities that we saw with the name field, date of birth, gender, and all those information that I need. Okay, very good. If we go back to the search part, when we are searching here, we are still searching using the database. We have injected data into Elasticsearch, but we are still searching within the database. To answer the question that I have, Elasticsearch does not support transactions, so you cannot roll back anything in Elasticsearch. So let's implement the search part now in Elasticsearch. Sorry, not this one here. So I shown you this search implementation. So what I'm going to do, I'm going to remove all that, and we are going to implement the Elasticsearch implementation for this. So we are going to start with a query, and let me build what I'm going to call that a text query, for example. And if the user has entered nothing at all, so if the query is empty, I will do the same thing that we did previously. So the text query I'm going to build is going to be a query, so again, off, and the query I want to have is what we call a match all query here. Here I have nothing to pass specifically. I don't have any option, so just match all query. Whatever the name is, we don't care here. Okay, so here, if the user has entered nothing, I have a match all query. Otherwise, I'm going to build another type of query. So let's use the same syntax, query off. And the query I want to build this time is what we call a multi-match query. Multi-match query. So I have a builder here. And with that, sorry, what I'm going to say, I'm going to set what the user has entered, Q, the parameter, and I'm going also to provide the fields I want to search in. So one of the first fields I want to search in is the name field, and I also want to search within the, I said, why not the gender field? Because everything is indexed by default in Elasticsearch. I can search within the address.country. Same goes for address.city. So I can search within those two fields. And now I can call my Elasticsearch DAO class. I need to implement a search method, and I'm going to provide the query. And I'm going to provide also the pagination information, so the from and size parameters. So let's implement this method. call that a query. Okay. So I'm going to use the same client that we saw. So let's call the ES client here. And I'm going to call the search method. So let's build a search request now. What is the index I want to search in? You can search across multiple indices at the same time if you wish, but here I want to search within the person index only. Okay, I can add an exception here. I need that. Yes, and something I need to provide as well is the response type class, and this can generate an exception. Okay. So yeah, I can I can search within the index person. What is the query I want to use? This is the query I have generated before. For the pagination, it's straightforward. You have from and size parameter. So the size is the size of the page, and from is the entity number you want to start from. Size is the size. And another feature I want to have is the track total hits, because there is an optimization in Elasticsearch. If you don't really care about the exact number of hits after 10,000, there is an optimization, and Elasticsearch will just tell you that there is more than 10,000 hits. Here, I want to be sure to get the exact number, so I'm going to enable this feature. Okay. Here, so I can get back the search response. What I can do now, I could iterate over the response and get every single hit. And this hit is going to be serialized as a person, so I can directly use this entity now. But what I want to do here, I don't want to focus on the front-end side, sorry. So what I'm going to do, I'm going to actually generate everything as a JSON document and send the JSON document directly to the interface. So I don't have to change the interface, basically. So to do that, I have, yes, a small helper here. And basically what I can do, I can call this thing, so I can return JSON to string of the response. Yeah. So that will be a JSON version of the response. So this is returning now a JSON version of the response. This is basically the same thing that we saw in the dev console, the same kind of response. And now I have that. So what I can do with that, I can just send that back to the interface. Okay, so that should be good. So that's okay. And what I need to do as well is to change the advanced search. Remember that we were able to search within specific fields here. I did not show you the exact SQL code there, which was running behind the scene, but it's straightforward to understand what was happening. I just want to show you how you can implement that within Elasticsearch. So basically, you build the same query as we did previously. If you have nothing coming from the interface within the name field and the country field and the city field, then you want to build again a match all query. Otherwise, the query you want to build is a Boolean query. If you have something set within the name field in the interface, it must match on the name field. If you have something coming from the country field, then it must match on the address.country field, and same goes for city. So basically, this is the code that you have to implement. Easy to understand. So let's restart the application again. And we are going to see what is happening now on the search side. So let's go here. Let's search again. You cannot really spot the difference. I know that I'm connected to Elasticsearch because here I can see the response time. It was around 10 milliseconds before, something like that. Now it's some few milliseconds. But let's search. Joe. As you can see, with GO, it does not work, but the full term is working. Okay, so the search engine is kind of working. Not exactly, but kind of working. Smith is working. And Smith Joe now is working, as you can see that. So whatever the position of the terms, the search engine is now working as we would expect previously. I can search within the gender field, why not? I can search within the city field, but only for the full terms again. I can search within the country field. And look now, France-Galles is on the top of the list, right? Automatically. Why this? Because France is a rare term in the name field. So the score that we are computing, that you can see here, is more important for this entity than for the other ones. So that's the reason the France is now on the first position. So let's have a look at the advanced search. If I search for GO, it does not work, but with the exact term, it works, okay? So we have to fix something. And to understand what is happening, we need to understand something about what is called the mapping in Elasticsearch. By default, when you don't tell anything to Elasticsearch, Elasticsearch generates automatically a mapping, a schema, if you wish. And this is the mapping that has been generated by default by Elasticsearch. If we look, for example, at the name field, what we see is that we have this name field which has this type of text, which means that we want to run full text search on it. Yes. But we don't specify how to analyze the text that has been sent by the user at index time, or to analyze the text what has been sent by the user at search time. Because we don't specify anything, the analyzer we are using is the standard one. And if you want to understand how an analyzer is working, you have this super powerful API named Analyze, where you can pass a text, so here Joe Smith, for example, and the analyzer you want to use. So here, at index time, when we index Joe Smith with this form, it generates two tokens, which are lowercase, Joe and Smith. Okay? But what is happening at search time? By default, we are going to use the same analyzer that we have been using at index time. So if we are searching for Joe, G-O, like this, it's producing this token, G-O, and this token does not match this GOE token. That's the reason we cannot find the information we are looking for. If we are searching for GOE, okay, it's generating the same token as we can have in the inverted index. That's the reason it matches. So what we can do? There are multiple strategies, but one of the strategies I want to show you is that you can change the way you are analyzing the content. So you can change the schema. So what I'm going to do, I'm going to create here a fake index named test, and I'm going to provide an analyzer that I'm calling ngram. I'm not going to explain in detail because I don't have enough time for that. I'm just going to show you the effect of what we call the edge ngram. If I'm analyzing this text, Joe Smith, with the ngram analyzer I created, now it's going to produce a lot of subtokens. Instead of GOE, I will have G, GO, GOE. Instead of Smith, I will have S, SM, SMI, etc. And at search time, if I'm using a simple analyzer, it will basically just do a lowercase of everything. So it will generate GO. And if I compare that with the text that has been generated at index time, GO is in the inverted index, so it will be able to match. So that's basically how I want to implement now my mapping. So to do that, I'm going to remove the index here, and I'm going to create a new index, and I'm going to explain what I did. So first, I created the ngram analyzer that we saw previously. What I'm doing here, let's have a look at the name field again. What I'm saying, for the name field, by default, at index time and at search time, I will have the same strategy because here I'm not specifying any analyzer. So I will still use the standard analyzer. If I look at what I have here in fields, at index time, I will generate a subfield based on the same content that has been provided within the name field, but I will generate a subfield named name.ngram. And for this one, I will use the ngram strategy that we saw. So at index time, the ngram analyzer, and at search time, the simple analyzer, which do only lowercase. For the other fields, I'm doing something similar. For example, for the gender, I'm doing the same thing. So if I'm searching within gender field, I will use again the standard analyzer. But if I'm searching within the gender.ngram field, then I will use this this ngram strategy that we saw. And I'm also generating for some fields the keyword, the keyword subfield, so gender.keyword. And this one is a type keyword. Keywords are super useful when you want to do sorting or when you want to do aggregations, for example. And because we are going to cover that in a moment, I'm doing this mapping here for that explicit reason. And if you look at the location, instead of having latitude and longitude subfields, I'm actually saying that location is a geopoint, and with that I can use that that data structure to actually do my whatever I need. So I have done everything here. So my mapping is ready. So what I need to do now is to index again new data. So let's index 100 person again. And if I go to the search part, where is that? Here, search. And if I'm searching again, if I'm searching for Joe, it still does not work. Why this? Because I'm not searching within the name.ngram field. So I need to fix that here in my application. Instead of searching within the name field, I'm going to search within the name.ngram field. And same for gender, same for country, same for city. And if it match with the exact term, I want to boost the name field and boost the result. So it will be much more relevant here with this notation. So let's compile that. Okay, it's done. And yeah, it's here. And if I'm searching again for G, O, E, as you can see, it matched now. France. Okay, and you can see the score because France is now, if I don't have the complete term, the score is around 4, but if I have the complete term now, it's boosted, as you can see. So that's perfect here. For the advanced search, it's the same thing. It does not work here. So if I want to change that, I just had to change the way I implemented here and search within the ngram field. Yeah, here if I'm searching for Joe, living in France, living in Paris, I have my result set as I had before. One of the things we can think about, sometimes I have this question, as you can see, the rate is 30 documents per second, but what is the actually speed of Elastic here? So let's have a look at this. What I'm going to change, I'm going to modify here the save method here. I'm not going to call anymore the database. I'm just going to send the information into Elasticsearch only. So let's do that. And because I'm doing that, I need to remove here the ID of the person because the ID will be generated by Elasticsearch now. So let's index again some documents now. Okay, it's done. So let's say 10,000. As you can see, it's much faster than it was previously. So let's inject 1 million documents, for example. And the cool thing is that when you are using Elasticsearch, while you are indexing your documents, as you can see, the documents are coming here in the interface, and I can search within a very efficient manner for everything that I have. So while this is injecting, and I know that I'm going to run a bit out of time in some minutes, but while this is injecting, I want to show you something. I want to show you how you can compute aggregations, because this is super interesting to see. And here in my Elasticsearch DAO, when I'm searching, I'm going to add here the computation of aggregation. So let me show you that here. So what I'm saying here, I'm asking Elasticsearch to compute an aggregation on the result set. So I want to group the result basically per country, and I want also to build a data histogram per year. So count the number of person per year. Everything has been done in the interface already. So if I just compile that and restart the interface, you will see what is the result. So whatever the size is, you can see here my documents coming again and again, and you can see the value increasing, broken per country or broken per years. And if I'm searching within the data, the Elasticsearch, sorry, you can see that it's super fast to get all this information. You can do multiple other things. I don't have enough time to show you everything. I think, yes, I have again 5 minutes left or so before the Q&A, I guess. So let me show you something else. Let's go to Kibana now. And in Kibana, what you can do, you can use the Kibana interface to actually also discover your data. So here I'm searching for my person within 1940 to 2010. And you can see that not everything has been indexed so far, but the documents are still coming. I can here add the fields I want to display, for example, those ones. And here I can search for Joe. So this is basically the same thing as you saw, but here you have a visualization of the representation. So this is basically the data histogram that we saw previously. And with Kibana, once you have indexed your data or in live, you can also create dashboards. So I built a dashboard already. So this is what I have so far. So this is the representation of my dataset. So it's just click and play. Everything is available in the free version, even if you don't run on cloud. So you have access to all those tools for free. So here you can see here my dataset. So I have my 1 million etc. data. So almost, yeah, everything is ready now. So this is some representation of my dataset. I can have representation per year, per gender, and per country. So those are aggregation and sub-aggregations. Here, over-representation of all that. I mentioned the geolocation points. So you can group the information using the geolocation points, for example. So I can zoom in here. Why not? And you can search for your people if you wish and analyze your data in real time. So here I have a full understanding of what my data set is made of. I can drill down to see all the women here. I can go to this city, why not? Yes, I can hear you. And for example, I have this Scarlett Joe with here available here. I think this is all what I have for you. I hope you enjoyed the session. Again, everything is available for free. Feel free to test it out. There is a Docker Compose script in my repository, which you can use as well if you want to run everything locally. Otherwise, just start your cluster on cloud and it's super easy. You have 15 days for free to use the cluster. I'm done. I can't hear you. You are muted, I think. Or it's me. No, I can't hear you. I can't. Yeah, okay. So I did not show you, but you can do other things in the Java application. And in the Java application, for example, one of the things I did not show, I can do that while it's coming back, is the fact that you can add what we call a fuzziness factor here for if you have typos, for example, you want to deal with.
Can you hear me now?
Yeah, I can hear you. So while you were not here, I'm just going to show this. Okay, so now if you have typos in the interface, where is my application? We get here again. if I'm searching for G small's, it's working as well. So I'm supporting typos within just this field.
Thank you for the great presentation, David. We have one question from
Yes.
Danius. He's asking,
Yes.
is the Elasticsearch support transaction?
Yeah, so I answered during the presentation actually. So the Elasticsearch does not support transactions, so you have to deal that by yourself. Some people, like the Hibernate search team, did something super smart. They are sending all the information into a message queue system, which is transactional. And if something goes wrong, they try to commit at the last point of time. But Elasticsearch is not transactional, not at all.
Mm-hmm. Thank you very much for your talk, for your time.
Yeah, you're welcome. Enjoy the day. If you have any other questions, yes, feel free to ask on the chat. I will be happy to answer.
Thank you very much. I hope to have you again with us.
Sure. In live, I hope.
Yeah.
Thank
you, attendees, for your attention. Hope to have a good time and the lecture to be informative for you. See you in the next session.
Goodbye.
Bye-bye.